Hi, fifth graders, it's Miss Roby. I hope you're all doing well, learning from home. I miss you a lot, and I'm excited to be able to do some math with you today and over the next few days. So, starting today and over the next couple lessons, we're gonna be working on dividing decimals. And as we think about dividing decimals, we're gonna think about something that we think about a lot in math, and that is, how can I use something I know to solve something I don't?
Okay, so I wrote down that question using a few different words, and I wrote down the question, how can I use what I know to solve new problems? Here's the problem that I'm going to start solving today. 18 divided by 6/10. If dividing decimals is new to you, you might be thinking, I don't know how to solve this problem. But I bet there are other problems that you do know that could help you solve 18 divided by 6/10. So let's think about a problem that we do know that might help us solve this. Let me just get a different color marker. Okay, I'm gonna write down the problem. 18 divided by 6. Notice how I changed the 6/10 to a whole number because I do know what 18 divided by 6 is, and I know that's 3. If you didn't know it was 3, you could do a few different things to figure it out, but you might skip count by 6s until you get to 18, 6, 12, 18. And there are 3 6s in 18. When we're trying to figure out 18 divided by 6, we're trying to figure out how many groups of 6 are in 18. And we determined that there are 3 groups of 6 in 18. So now let's return to this new problem, 18 divided by 6/10. Well, similarly to down here, I do know that I'm trying to figure out how many groups of 6/10 are in 18. Just like I did when I was trying to figure out how many groups of 6 were in 18, I could skip count by 6/10 to figure out how many 6/10 are in 18. I could skip count and start at 6/10 and go 6/10, 1 and 2/10, 1 and 8/10, and keep going until I got to 18. However, that feels like it's going to take me a long time, and I think I can figure out a more efficient strategy. So let me look at these numbers. Okay, how many 6/10 are in 18? Well, I know it's not going to be 3 for a few reasons. It's not going to be the same answer as I had down here because this number changed. I don't have 6 anymore. I have 6/10. I also know it's not going to be 3 because I just skip counted by 6/10 3 times, and I got to 1 and 8/10, and that's not the same as 18. I know that it's going to be bigger than 3. It's going to be bigger than 3 because when I counted 3 times, let me just write that back down so we can see it. When I skip counted 3 times, I was only at 1 and 8/10. And it's going to take me many more 6/10 to get all the way to 18. It's not 3, and it's more than 3. And let me think about how much more than 3 it's going to be. I'm looking at the relationship between this 6 and this 6/10. This 6/10 is 10 times smaller than this 6. So that gives me a hint that it's probably going to take me 10 times as many as it did down here to fit 6/10 into 18. So I'm thinking that it's going to take 30 6/10 to get to 18. If I have 30 groups of 6/10, I will have 18. I know I said I wasn't going to skip count by 6/10 until I got to 18, but I just wanted to prove to you guys that it did actually take 36 tenths to get to 18. So you can see down here, I skip counted by 6 tenths, 1 and 2 tenths, 1 and 8 tenths, 2 and 4 tenths, until I got to 18. And then I just counted all of these up, 1, 2, 3, 4, 5, counted all the way. And it took 36 tenths to get to 18. So this is correct. There are 18 divided by 6 tenths is 30. This number is 10 times smaller than this, and my answer is 10 times greater than this, which is interesting. So let's look at another problem. Here's my new problem. 18 divided by 6 hundredths equals what? I kept the problem that I started with over here, 18 divided by 6 equals 3, because that helped me solve 18 divided by 6 tenths, and I have a feeling it's going to help me solve 18 divided by 6 hundredths. I'm thinking that I know my answer, my quotient, is going to be related to 3, because 18 and 6 and 6 tenths and 6 hundredths, they're all related. The 6 is just getting smaller by powers of 10. So here it got 10 times smaller. Now it's 100 times smaller than 6. So I now need to think about how many 6 hundredths will fit in 18. And 6 hundredths are super small, smaller than 6 ones, smaller than 6 tenths. So it's going to take me more hundredths, more 6 hundredths, to get to 18 than it did to get to 18 using 6 ones or 6 tenths. And I'm going to think about this relationship again. If I have 6 hundredths and I'm going to get to 18, I'm thinking that my answer is going to be 300, because I'm noticing this pattern here. When I had 6, my answer was 3. I made my divisor 10 times smaller, and my quotient grew 10 times. Now I made my divisor 100 times smaller, and I'm thinking that my quotient is going to grow 100 times. Okay, let me just check to see if my prediction was correct. Is 18 divided by 6 hundredths equal to 300? Yes. This pattern I noticed is working. Did you guys see that same pattern that I saw? It's interesting. You ready for a new one? Okay, here's my new problem. 35 divided by 7 tenths. Now, I have this decimal again that's kind of looking tricky, but I know that I can use what I know about dividing whole numbers to help me divide decimals. So I'm gonna change this into a problem with whole numbers that I do know how to solve. And I know how to solve 35 divided by 7. How many 7s are in 35? Well, I could skip count by 7s. 7, 14, 21, 28, 35. 5 7s are in 35. Or you might have just known that division fact in a snap, which hopefully you did. Hopefully you knew 35 divided by 7 is 5. So let's think about how we can use that to help us solve 35 divided by 7 tenths. I'm looking at the relationship between the 7 and the 7 tenths. 7 tenths got 10 times smaller than it was up here. So that's telling me I'm gonna need more of these to get to 35 than I needed of these 7s. Because if I started counting by 7 tenths and I went 7 tenths, 1 and 4 tenths, 2 and 1 tenth, 2 and 8 tenths, it's gonna take me such a long time to get to 35. Much longer than it did to get to 35 when I was counting by 7s. So it's gonna take me more 7 tenths to get to 35, but I know that my quotient's gonna be related to 5. It's going to be more than 5, And it's going to grow by a power of 10, just like these numbers change by a power of 10. So this 7/10 was 10 times smaller. So that's giving me a hint that my quotient is going to be 10 times greater. It's going to take 57/10 to get to 35. And now I can apply that to dividing by hundredths. 35 divided by 7/100. Let's think for a minute. Is 7/100 more or less than 7/10? Hundredths are smaller than tenths. Hundredths are 10 times smaller than tenths. So once again, this divisor is getting smaller by a power of 10. It's 100 times smaller than 7. So it's going to take me way more 7/100 to get to 35 than it took me 7/1 to get to 35. And let's look at this relationship again. 7/100 is 100 times smaller. So my quotient is going to be 100 times greater. It's going to take me 500 7/100 to get to 35. I want you to look at these 3 division problems, and I want you to, in a second, pause your video and say out loud what relationship you see between the 3 division problems. Here's the pattern that I noticed, and I wonder if you said and noticed the same thing. I noticed that as the divisor, that's 7, as the divisor changes by a power of 10, the quotient, the answer, also changes by a power of 10. I'm going to show you a misconception, a mistake that a lot of people make when they divide decimals, so pay close attention. See this problem 24 divided by 6/10? You might look at this and say, okay, I can use what I know about 24 divided by 6 to help me solve this. And I know that 24 divided by 6 is 4. So let's look at this. 6/10 is 10 times smaller than 6. So my answer must be 10 times smaller as well. So my answer must be 4/10. This is not correct. Let me get my red marker to make sure we know. This is not correct. When we're dividing decimals, when our divisor got 10 times smaller, that means it's going to take 10 times more of these to fit into here than it did here. So our answer is definitely not going to get smaller. It's going to get 10 times greater. So let's look at that one more time. If I have 24 divided by 6/100, let's think. Is it going to take me more of these to fit into this than it did 6/1? Yeah, because these are smaller. And so my quotient is not going to get smaller than 4. It's going to get 100 times greater or bigger than 4. Okay, my friends, are you still with me? It's your turn now to solve some problems. Here are the 2 problems I want you to solve. 32 divided by 4/10 and 32 divided by 4/100. Pause the video, take out a pencil, a piece of paper, and solve these 2 problems. And then once you have your answers, come back and we'll check in to see if we have the same answers. So I used 32 divided by 4 equals 8. Change the problem into whole numbers to help me solve these 2 new problems. 32 divided by 4/10 is 80. 4/10 is 10 times smaller than 4. So it's going to take 10 times more 4/10 to fit into 32. 32 divided by 4/100 is 800. 4/100 is 100 times smaller than 4. So it's going to take 100 times more 4/100 to fit into 32. I'm glad we got to do some math together today. If there's one thing you take away from this lesson, I hope it's that you know that when you see a new problem that you don't know how to solve, you can think about problems that you do know how to solve to help you. You're going to do some more practice dividing decimals today. If you have questions, write them down so you can ask me, your teachers, or other classmates on Google Classroom. See you guys tomorrow to do more dividing decimals.